This is the prep packet video for Unit 3, Chapter 8.5, and we're going to look at objective number 3. For objective number 3, we're looking at applications involving work, not job applications. That's something different. With work problems, we are looking for, it's like a rate times time problem, so it's like distance, except now we're looking for completed jobs instead of distance, but you're still using rate and time. Now, if I can finish a job in 3 hours, that means I can do 1/3 of the job in an hour. Okay, that means 1/3 for the first hour, 1/3 for the second hour, 1/3 for the third hour. That's one job in 3 hours. If I work for 2 hours, I can do 2/3 of it. If I work for 3 hours, I'll have 3/3 of it and I'll be completely done, or 1. Now, if you can do the same job in 2 hours, that means that you can do 1/2 of the job in an hour. That's your unit rate. And if you work for 2 hours, you'll have completed the whole job. The question that these problems usually ask is, what if we do it together? How long, big deal, will it take to finish the job? What we're going to do is we'll combine our efforts to equal one complete job. So in this case, you have a rate of jobs per hour. So you can do 1/2 of a job in an hour. I can do 1/3 of a job in an hour. And what I've noticed with these problems is that they often are talking about the same amount of time. So we're both working together for how many hours to get to 1. And the way we figure that out, it's basically we're combining. These are called combined rates. Your work plus my work equals one whole job. So if you look at it this way, we've got rate times time for you, and rate times time for me makes one whole job, okay? Rate times time for your rate, rate times time for my rate, and that will equal one job. So let's take a look at how this works. You work at 1/2 job per time, and I work at 1/3 of a job in that amount of time. And together we make a complete job. To make this work, you can't combine fractions, even if they're coefficients, unless they have a common denominator. So you have to do that. 2 and 3 have a common denominator of 6. So 1/2 is the same as 3/6. 1/3 is the same as 2/6. I combine my pieces and I end up with 5/6t equals 1. To make clear the fraction, I multiply both sides by the reciprocal. The reciprocal is 6/5. 6/5 times 1 is 6/5. So if you and I work on this mystery job together, we will be finished in 6/5 of an hour. Now, this is one of those little things that I know I always say not to take something out of an improper fraction and not to waste your time with mixed fractions. But this is one of those cases when you need to not follow my instructions. For the simple reason that hardly anybody ever comes up to you and says, we'll be done in 6/5 of an hour. That's not how we talk about time. Instead, you would say, we'll be done in 1 1/5 hours. And really, frankly, you would get down to minutes, but we're not going to spend that time here. So think about things logically, how you would report time, not as an improper fraction, but as a mixed number. So again, they want us to solve for time, so that's our variable. Your work plus my work makes a whole job, and then we report as a mixed number, which is how we think about time. Let's try another problem, the one that's actually on your sheet. In this question, we go into it knowing that it's a work problem, so we don't have to make any big decisions that way, but let's read it. If it takes Marshall 12 hours to refinish the hardwood floor in his house while his brother Nellie can do the job in 10 hours, how long would it take for them to refinish the floor together? So if the first brother can do it in 12 hours, that means he would do 1/12 of the job in an hour. That's his basic. Let me make that better. 1/12 of the job in an hour. This other brother could do it in 1/10 of a job in an hour. We don't know how long it's going to be, but they're going to be working together, so time is the same. And in this case, they're not each doing an individual job. Together, they are doing one job. This is combined rates. So let's take a look at how that's going to look. I'm going to have person number 1 works 1/2 times T, and person number 2 works, that's 1/12 times T, 1/10 times T. And together, working together, they'll finish one job. Again, we're looking for common denominators. I'm going to be lazy and just say I'm going to use 120. So 12 goes into 120 10 times, so that's the same as 10 over 120 T. Again, erase and make it right. No messy writing. I lost my cursor. There it is. Plus 10 goes into 120 12 times. So I have 22 over 120 T equals 1. Multiply both sides by the reciprocal. I'll have T equals 120 divided by 22. Before I do any fancy schmancy division, I'm going to do some canceling. I'm going to divide that by 2 and I'll get 60, and I'll divide that by 2 and I'll get 11. And again, that's an improper fraction. Break it down and you'll end up with 5 hours, let's see, and 55 and 5/11ths of an hour. Again, in the real world, I would probably make you break it down to minutes, but I'm not that mean right now. So the big thing in here, figure out the person's rate times the time equals their part of the job. And this person's rate times time if we combine the two of them, we get one job. So go ahead and copy, and we'll see you in the next video. Thanks a lot.